Hello, this is Katish here. In this video, I'm going to go through the AQA 2018 Paper 1 Higher Tier for the Combined Science. Question number 6 is on the topic of electricity. A student built a circuit using filament lamps. Sketch a current potential difference graph for a filament lamp on figure 9. So we've got the current and the potential difference. So how would you draw this? Right. Drawing on this, right? The midpoint is actually has to be a straight line, right? The graph itself is actually a S-shaped graph. So I'm going to choose a dot there and dot there. Between those 2 points, I'm going to try and draw a straight line. And above that point, it actually curves. It looks like a S-shape, right? That is the graph for a filament lamp, the current potential difference graph for a filament lamp. Now, in GCSE, they are going to ask you to try and remember the shape of 3 different graphs for potential different graphs. This is one of the required practicals. So let me give you some notes on this. The 3 graphs that you need to remember is this shape. You have the fixed resistor, which is actually a straight line going through the origin. The filament lamp, which is what I've attempted to draw on the top. It's a S-shaped graph. And for a diode, it's actually 0 on the negative side and 0 up to a certain point, and then it increases sharply, right? Remember, diodes only let current in one direction, right? Filament lamp, a resistor, that's okay, right? It behaves the same way even if you reverse the current. So the notes that you would want to write is this, right? For a fixed resistor, we say that it obeys Ohm's law. If it's a straight line, right, then we say it's actually obeying Ohm's law, because Ohm's law says that as the potential difference increases, the current also increases, provided the temperature is kept constant, right? That's key. Here, the potential difference is directly proportional to the current, and the gradient should be equal to the resistance from the graph. For a filament lamp, we can say that it is obeying Ohm's law, where the line is actually straight. It is obeying Ohm's law for low current or PD values. At higher current, the resistance increases, right? Remember, current is the rate of flow of electrons or charge. So if there's more charge flowing through the filament, then the number of collision increases. That increases the temperature as well. So at high current, resistance increases as temperature of filament increases, then becomes stable as rate of heat loss to surroundings becomes stable. Now this point is mainly for higher tier types of answers, if you're looking to describe why it actually happens. For a diode, 0 current in negative direction. As diode allows current in only one direction, at very low current, PD 0 then increases after a certain point. We can say it increases drastically or exponentially, maybe, right? But they don't actually ask too much detail about why it's actually increasing. So you just need to remember mainly the shape, and you should be able to describe in Ohm's law. You could say that a diode doesn't actually obey Ohm's law. Next question. Figure 10 shows the circuit with 2 identical lamps. Now that's key, because they've said it's identical lamps, right? Remember, that's going to be important. Compare the currents in I1, I2, and I3. So I1 is the total current in the circuit. So it's coming straight from this branch. and that branch actually splits into two for the first bulb and then the second bulb. So the key points that you need to remember when it comes to series and parallel circuits: what happens to the current in a series circuit and the potential difference, and then for a parallel circuit, the same thing, what happens to the current and the potential difference. So it's worthwhile making a note here. In a series circuit, the current is the same at any point in the circuit. So if you were to just consider this first, the top half as the, where did the mouse go? So if you consider this part as just one circuit, ignore the lower part, then the current is always going to be the same before the bulb or after the bulb. It doesn't matter. And even if it had 10 bulbs, the current is always going to be the same. So the current is the same at any point in the circuit. The potential difference is shared between the components. So if you had two bulbs, then it will be shared. So if it was 9 volts here, it will be 4.5 and 4.5. That's why this is important that you understand it has to be two identical filament lamps. If it wasn't identical, then it will be different. In a parallel circuit, the current I1, which is the total current, splits up at the junction here equally because they are identical lamps, and then joins back up again to maintain the total current before it returns to the negative side of the cell. So the question is asking, compare the currents I1, I2 and I3, right? So we can start off by saying I1 is equal to I2 plus I3. So these two currents should add up to the total current. So that's the, I can mark it here, that'll be the total current. And I could also say that I2 is equal to I3. Right? Because the current is going to be the same between these two branches, mainly because the lamps are identical here. That will give you the 2 marks. So as a note, again, in a different way, if I add this box at the bottom, that summarizes the current, voltage, and also the resistance. But the resistance bit for the parallel circuit is not required for GCSE. So let me make a note of that, right? Not for, okay, just that bit, right? Rest of it you need to know. And features of a series circuit: if one component burns, the current becomes inactive or the total circuit doesn't work. In a parallel circuit, if one component burns or actually stops working, the current stops only through that branch. The rest of the part works fine. Question 6.3. Now this is a 6-mark question. It's a really nice question because it's just calculation for 6 marks. Remember, your paper is out of 70 marks. So this 6 marks is going to give you nearly 7 marks would be 10%. So you're going to get at least 8% of the total marks available if you get this question right. So what are they asking? Calculate the charge that flows through the cell in 1 minute. So they want you to calculate the charge. The symbol for charge is Q. The cell in 1 minute. Minute is the time, which is going to be, remember, it has to be in seconds. So let me convert that to seconds here. So all these little bits of conversion is going to give you a mark. So this is going to give you a mark there to final answer, and the unit is definitely a mark there. Even if you didn't write the answer, if you wrote down the unit for charge, if you remember it, that's going to be 1 mark. So it's worthwhile to pick bits and pieces and see if you can answer parts of the question. So each filament lamp has a power of 3 watts. Power is 3 watts. Resistance is 12 ohms. This symbol is called ohms. Write any equation that you might use. Now, because it's a 6-mark question, you are definitely going to be using 2 equations here, right? It's not going to be straightforward, so you have to use 2 equations. What equation can I use now? In order to find the charge using the time, if I know the current, then I can actually use current equals charge multiplied by the time, right? Now, actually, let me rearrange that. Yeah, Q equals IT. I've written the equation incorrectly. Okay. The equation which involves Q equals IT. So if I know the value of the current, then, and I know the time here, which is 60 seconds, I can find out the value of the charge, which is what we want. In order to find the current first, I can use the power and the resistance value. Now for that, I will have to use this equation. P equals I squared R. Power equals the current squared multiplied by the resistance. Now, if I rearrange this, I is, to get rid of the R on this side, I'll have to divide both sides by resistance. That would be power divided by the resistance. We'll get rid of this R. To get rid of the square sign, I will now have to find the square root. So power is 3 divided by 12. Find the square root of that. So let's find what the value of 3 divided by 12 is. 3 divided by 12 is 1 over 4. Yeah, and that's 0.25. So square root of 0.25. Let's find that. Square root of 0.25. And that's 1 over 2, which is 0.5. So that's 0.5 amps. Now this is, remember, step 1. So the first step. So that would be step 1 there, and this is step 2 there. So using that 0.5 amps, 0.5 multiplied by the time, which is 60 seconds, that gives me 30. So just to verify that, multiply that by 60 gives me 30, capital C, for coulomb. So that's 30 coulombs. Now remember, this is probably going to be the final mistake if you did make it, because it took me a while to figure out. Right, so this is for each filament lamp that you're actually finding using the power and the thing. Because you have 2 lamps, they're asking for the charge that flows through the cell, that is the total charge. Right, so total charge is 30 times 2, because what we found is either I1 or I2, which is the same. So you need to multiply that by 2 to get 60. So 60, the unit is coulombs. Right? You can write the symbol or write the word COULOMBS. Better write the symbol. Now, without the working, you still get 5 marks for the charge and 1 mark for the unit. Next question. Question 6.4. The student builds a different circuit. Figure 11 shows the circuit. So you got a power supply here. So let's label some of this. So a cell, ammeter, a voltmeter, this is a LDR, light dependent resistor. This is a fixed resistor. Now this circuit is a series circuit. The voltmeter is connected to it parallelly, but it's a type of meter, so you don't actually consider that as part of the main circuit. So this is actually a series circuit with a fixed resistor and the LDR, where you have an ammeter connected in series to the circuit and a voltmeter connected in parallel to the LDR. Now, this is where it's important to remember what happens to the current and potential difference in a series circuit and a parallel circuit. Explain how the readings on both meters change when the environmental conditions change. So now the light dependent resistor, the resistance is going to change depending on the environmental conditions. That's linked to this environmental conditions. Now what is the environmental condition? Whether there is light or not, that's the environmental condition. Now the resistance of this resistor is controlled by how much light falls on this resistor, right? When light falls on it, the resistance actually goes down. That is the key thing that you need to remember here. If you remember that, then the next couple of points will actually flow through. So first bullet point, what happens in the light dependent resistor? Resistance of the LDR changes when light intensity changes. Now how does that change? When the light intensity increases, the resistance of the LDR decreases, meaning that it's going to allow more current to go through it. Right? So how does that affect the current in the ammeter and the voltmeter? Right? If you can describe those, then you're going to get the rest of the marks. Right? So when this happens, when the light intensity increases and the resistance of the LDR decreases, the overall resistance of the circuit decreases. Now, remember that total resistance in the circuit, right? If I write RT in a series circuit is resistance of the fixed resistor added to the resistance in the second component, which is the LDR, right? So if this goes down, then the total resistance should ideally go down, but it will. So the total resistance is going to go down. That means the current is going to increase. Reason, the potential difference from the cell is not actually changed, right? So V equals IR, this equation. If you don't change this, right, in order to maintain the same potential difference, if the resistance drops, the current should increase to maintain the potential difference. So how do we write that bullet point? This causes the overall resistance of the circuit to decrease. However, the potential difference across the total resistance of the circuit remains unchanged, meaning the power supply, let's say 9 volts cell, the 9 volts is not going to change. So the current in the ammeter increases, right? So you're referring to this equation, V equals IR. So how do you get the next couple of marks, right? Since the potential difference is shared between the components in a series circuit, the lower the resistance of the LDR, the smaller its share of the potential difference, and the potential difference across the fixed resistor increases, right? So the resistance is lower here. That means it's going to use up less energy. Fixed resistor's proportion of energy being used, which is the potential difference, is going to increase. So the voltmeter reading goes down, right? And the potential difference across the fixed resistor increases, causing the reading on the voltmeter to decrease, right? Remember, you're explaining why it's actually happening. That's why it's 6 marks. You need to be explaining all of these changes. So the main change is what is happening in the current in the ammeter and the potential difference in the voltmeter. Main 2 points for 2 marks, and the rest of the 4 marks is for your explanation. That's the end of this question and this paper. Thank you for watching the video. If I have made any mistakes, please leave a comment, and if you think I can improve these videos, again, leave a comment. Thank you, and I shall see you in the next video.